The stern began to slide toward the starboard breakwater just as the main engine failed to give the kick ahead we needed to correct the swing. We were drifting sideways, closing the distance to the rough stone blocks, and the rudder was hard over, with no water flow to bite against. The pilot looked at the RPM indicator, then at me, waiting for a vibration that was not coming. The heavy swell lifted the quarter, pushing us further off our line, while the bow pointed uselessly toward the open water of the basin. We were arriving at a port on the Atlantic coast of Morocco. The vessel was a 30,000-ton handy-sized bulk carrier, fully loaded with grain. It was late afternoon and the visibility was clear, but the sea state was marginal for entering this specific harbor. A long, rolling swell was running from the northwest, following us in. The entrance to the port was protected by two large breakwaters, but the gap between them was not particularly wide. With a following sea, the water tends to push the ship forward, making steering difficult unless you maintain higher speed. However, we had to slow down to make the sharp turn to port immediately after passing the breakwater heads. I was on the bridge with the local pilot, the third officer, and an experienced, able seaman on the wheel. The chief officer was forward with the anchor party and the second officer was aft. The wind was blowing about force 5 on our port quarter. This wind, combined with the swell, meant the ship wanted to weathercock. The stern would seek the wind and the bow would fall off. We needed to keep the engine ready for immediate bursts of power to maintain rudder effectiveness. The main engine was a standard slow-speed diesel. It was generally reliable, but on this trip, the response from the control room had been slightly slower than usual. The chief engineer had checked the system and found no alarms, attributing it to a minor lag in the governor response during the load changes. This happened in 1998 on a routine commercial voyage. The approach required us to come in at about 6 knots. Any slower and the following swell would take control of the rudder. Any faster and we would not have room to stop inside the basin. The pilot was a calm man, familiar with these waters, but he watched the swell pattern closely. We lined up the leading lights, keeping the vessel slightly to the port side of the channel to allow for the drift. Before I tell you what happened next, please consider subscribing. It helps this channel reach more sailors. The pilot ordered slow ahead, the telegraph rang, and the engine RPM dropped. We could feel the ship settle into the water as the speed decreased. The breakwater heads loomed large on the radar, less than half a mile away. The noise of the swell breaking against the outer rocks was audible through the open bridge wing door. The trouble began just as the bow passed the outer limit of the breakwaters. A larger set of swells rolled in behind us. The first wave lifted the stern and pushed it aggressively to starboard. Because we were at slow ahead, the rudder authority was minimal. The bow immediately swung to port toward the center of the channel, but the stern was now siding toward the starboard breakwater tetrapods. "Hard port," the pilot ordered quietly. "Half ahead." The helmsman spun the wheel. The third officer rang the telegraph to half ahead. We needed the wash from the propeller to hit the rudder and swing the stern back to the center. I watched the tachometer. The needle sat at 45 RPM. It did not move. The ship continued to slide. The stern was moving closer to the rocks. The distance was perhaps 80 meters, closing steadily. Without the engine power increasing, the hard-over rudder was just a steel plate dragging in the water, creating drag but no lift. "Engine is not answering, Captain," the third officer said. He was looking at the revolution counter, his hand still resting on the telegraph handle. I stepped to the console. The telegraph showed the command half ahead, and the reply from the engine room was matched. The system knew what we wanted, but the engine itself was hesitating. It was likely a fuel limiting issue or a slight delay in the scavenge air pressure building up, preventing the governor from adding fuel quickly. In open water, a 10-second delay means nothing. Here it meant we were losing our margin of safety. The pilot looked at the wing. "Captain, I need that kick. We are losing the stern." The gap to the breakwater narrowed to 60 meters. The swell was relentless. Another wave caught the quarter, pushing us further sideways. The ship was crabbing. We were moving forward into the harbor, but we were also moving diagonally toward the stone wall. If the stern struck the breakwater, the propeller and rudder would be destroyed instantly. I grabbed the telegraph and rang full ahead. Usually jumping from slow to full is not good practice for the machinery, but we needed immediate wash over the rudder. I waited. The seconds stretched out. The vibration on the deck plates remained minimal. The engine was turning, but it was just windmilling at the slow speed, not driving. "Rudder's hard over, sir," the helmsman confirmed, his voice steady but tight. We were now 50 meters from the rocks. I could see the individual concrete blocks clearly. The water between our hull and the breakwater was churning with the backwash of the swell. If the engine did not bite in the next few seconds, we would have to make a very difficult choice. I looked at the pilot. He was gauging the drift, his jaw set. We were too fast to drop the anchor effectively. It would likely drag or part the chain, but we were too slow to steer. We were in the dead zone of maneuverability. The massive gray wall of the breakwater seemed to be pulling us in. The vibration we had been waiting for finally ran through the deck plates. The needle on the tachometer jumped from the idle speed, climbing steadily past 50, then 70 RPM. The engine had taken the load. The delay had only been perhaps 20 or 30 seconds, but in that narrow gap, the swell had pushed us to the very edge of safe water. As soon as the pilot heard the turbocharger whine, he shouted, "Midships, hard starboard." This was the critical correction. In the previous moment, with the rudder hard to port and the engine stopped, we were trying to swing the bow. But now, with a burst of full ahead power, keeping the rudder to port would have kicked the stern violently to starboard, directly into the breakwater we were trying to avoid. By shifting the rudder to hard starboard, the pilot was using the propeller wash to push the stern to port away from the stone blocks. The helmsman spun the wheel rapidly. The rudder angle indicator swung over. For a few seconds, it felt like the ship would not react. The momentum of the swell was still carrying the quarter toward the wall. I walked to the starboard wing. Looking down, I could see the wash from the propeller churning white against the dark blue of the swells. The water between the hull and the breakwater was compressed, turbulent, and angry. We were less than 20 meters off the stones. Then the hydrodynamics took over. The bite of the rudder, combined with the sudden forward thrust, checked the sideways drift. The stern stopped closing on the wall. We surged forward, clearing the breakwater head with very little room to spare. The noise of the waves crashing on the breakwater faded as we slipped into the smoother water of the outer basin. "Stop engine," the pilot ordered immediately. "Midships." We were safe from the rocks, but now we had a new problem. The burst of full ahead required to save the stern had given us too much speed. We were entering the harbor at nearly 7 knots. The stopping distance of a fully loaded handy-sized bulker at that speed is significant, and the turning basin was only half a mile ahead. To make matters worse, the 2 harbor tugs were waiting for us further inside, near the grain berth, expecting a slow approach. They were not made fast yet. The ship carried its way heavily in the calm water of the harbor without the resistance of the head seas. She did not want to slow down. The pilot picked up the VHF radio. He spoke rapidly in Arabic to the tugmasters, then switched to English for me. "Captain, tell the tugs to come alongside immediately. We need them to act as brakes. We are too fast." I relayed the order to the forward and aft stations. "Chief officer, second officer, take tug lines as soon as possible. Do not wait for heaving lines if you can reach them. We have excessive speed." The tugs realized the situation. I saw the black smoke rise from their stacks as they accelerated toward us. They had to match our speed, 7 knots, to make fast safely. If they tried to push or pull before they were secured, the lines would part or they could be dragged under the hull. Thus, third officer rang the telegraph to slow astern. We needed to take the way off, but we had to be careful. The engine had already shown it was sluggish. If I asked for full astern and it failed to start, or if the transverse thrust swung the bow the wrong way, we would run out of room. The basin narrowed ahead with a concrete quay straight in front of us. "Engine is answering astern, sir," the third officer said. 40 RPM. The propeller churned the water, but a loaded ship has immense momentum. The speed log dropped slowly, 6.8 knots, 6.5 knots. It was not dropping fast enough. The turning basin was approaching. We needed to make a 90-degree turn to starboard to align with the berth, but we could not make that turn at 6 knots without risking the ship swinging wide and hitting the opposite bank. The forward tug moved in under the port bow. I watched the chief officer on the forecastle deck. He was directing the crew calmly despite the rush. They lowered a messenger line. The tug deckhand grabbed it. We needed that line fast. "Captain," the pilot said, his voice flat, "we cannot stop on engine alone. The distance is too short. We need the anchor." This is a standard emergency maneuver, but it requires precision. If you drop the anchor while moving too fast, the chain will run out uncontrollably. The brake will burn and you will lose the anchor and chain at the bottom of the harbor. Or the chain will hold and the shock load will damage the windlass or the hull. But we had no choice. We needed drag. How would you handle this from the bridge? Would you risk the anchor or trust the tugs to catch you in time? I made the decision. "Chief Officer," I said into the UHF radio, "stand by starboard anchor. We are going to dredge it. Do not let go until I tell you. Have the brake tight, then open gradually." "Standing by starboard anchor," the chief officer replied, ready to let go. We were now at 5.5 knots. Still too fast for a safe anchor drop, but the key was looming. "Let go," I ordered. "Pay out one shackle on deck. Hold the brake." The sound of the hammer knocking the pin out was audible, followed by the roar of the chain running through the hawse pipe. Dust rose from the windlass. "Hold it," I said. The chief officer tightened on the brake. The chain snapped tight. The ship shuddered as the anchor bit into the harbor mud. The bow dipped slightly. The speed log dropped. 5.0, 4.5. The anchor was dragging along the bottom, acting as a plow. This is dredging. We were not trying to stop the ship instantly. We were using the friction of the fluke and the chain to bleed off energy. "Slack the cable, let it run slightly, then hold," I instructed. We didn't want to part the chain. The chief officer feathered the brake, allowing the chain to slip when the tension got too high, then clamping it down again to maximize the drag. By now the aft tug had made fast on the port quarter. "Tug fast aft," the second officer reported. "Tell the aft tug to..." "Pull straight back, full power," the pilot said. I relayed the order. The tug moved into position and applied power. The combination of the engine running slow astern, the anchor dragging on the bottom, and the aft tug pulling back finally began to kill our momentum. The speed dropped to 3 knots. The bow began to swing to starboard, pivoting on the digging anchor. This was actually helpful, as we needed to turn starboard for the berth. "Forward tug is fast," the chief officer reported. He was covered in rust dust from the chain, but the anchor was holding. "Stop engine," I ordered. The vibration ceased. We were now under control. The speed was down to 1.5 knots. We were in the middle of the turning basin, the bow held by the anchor and the forward tug, the stern held by the aft tug. The pilot let out a long breath. He picked up his coffee cup, which he had set down on the radar console 20 minutes ago. "That was close," he said. "The engine lag at the entrance. Very bad timing." I looked at the RPM indicator. It was at 0. The engine had performed when we absolutely needed it, but that initial hesitation had triggered a chain of events that nearly put us on the rocks, then nearly put us on the quay. We were now stopped, but the maneuver wasn't over. We had a dredging anchor on the bottom with one shackle out, and we still had to get alongside the berth. "Heave up anchor," I ordered the chief officer. "Let's get it back in the pipe before we move to the berth." "Heaving up," the chief replied. But as the windlass began to turn, the hydraulic tone changed. It whined, high and strained. The chain did not move. The anchor had snagged on something solid on the harbor bottom, perhaps an old cable or a rock ledge. "Captain, anchor is not coming," the chief said. "Windlass is straining." We were drifting slowly toward the shallow water on the port side of the basin. The tugs were holding us, but we were tethered to the bottom. We could not approach the berth until the anchor was clear. The pilot looked at me. "If we cannot clear it, we have to slip it," he said. "Try to walk it out," I told the chief. "Slack it. Let the ship move astern with the tug, then heave." We spent the next 10 minutes gently maneuvering the 30,000-ton vessel forward and aft with the tugs, trying to unhook the fluke from whatever it had grabbed. It was delicate work. If we pulled too hard, we risked damage. If we drifted too much, we would ground the stern. The calm water of the harbor belied the tension on the bridge. We were stopped, but we were stuck. We could not simply pull the anchor up vertically. If the fluke was wedged under a rock ledge or hooked on a heavy abandoned chain, maximizing the tension on the windlass would only burn out the hydraulic motor or part the chain. We had to use the mass of the ship to unseat it. "Slack away the cable," I ordered. "Pay out until the chain is up and down, then give me a little loop on the bottom." The chief officer reversed the windlass. The chain rattled out slowly. "Chain is slack," he reported. I spoke to the pilot. We will move the vessel slightly ahead and to starboard. We need to get the hawse pipe directly over the anchor, and then perhaps slightly past it to flip the fluke backward. The pilot agreed. He instructed the forward tug to push gently on the port bow, while the aft tug stopped pulling and just followed us. I gave a kick on the engine, dead slow ahead, just enough to get the propeller turning, then immediately stop. The ship crept forward. We watched the direction of the chain from the bridge wing. It shifted from leading astern to hanging vertically, up and down. "Heave away easy," I told the chief officer. "Tell me the amp load." The windlass began to turn. The hydraulics groaned slightly, but the chain came in. The chief officer watched the links coming over the gypsy. "Load is high. Heavy strain," he said, pausing the operation. Then, "It's breaking out." There was no sudden jerk, just a change in the sound of the machinery. The high-pitched whine dropped to a steady hum. The chain was coming in smoothly now. "Anchor is away," the chief reported. "Sight and clear." I let out a breath. "Heave home and secure." We were now free to dock, but we had drifted slightly out of position during the 10 minutes we spent wrestling with the ground tackle. The berth was 300 meters away on our starboard side. We needed to traverse sideways. The pilot resumed control of the tugs. "Forward tug, push half power. Aft tug, push half power." The tugs leaned into the hull. The ship began to move laterally toward the concrete quay. I watched the distance closing. We were parallel to the berth. The water between the ship and the quay narrowed. "Dead slow ahead," the pilot ordered, just to position the manifold opposite the loading arm. The engine answered immediately this time. The ship inched forward. "Stop engine." We were 10 meters off. The deck crew threw the halving lines. The long, thin ropes arced over the gap and landed on the quay. The linesman ashore grabbed them and hauled the heavy mooring ropes across. "Send the springs first," I ordered. "The back springs are the most important lines when docking. They prevent the ship from moving forward or aft while you work the other lines." The wire ropes went tight on the bollards. "Dead slow astern," the pilot said to check the final forward motion. The propeller turned over. The water churned at the stern. The ship stopped completely. "Finished with engines," I said. The time was 1845. We were alongside, secured with 4 headlines, 2 springs forward, 2 springs aft, and 4 stern lines. The gangway was lowered. The pilot shook my hand, signed the chit, and left the bridge to go down to the main deck. I turned the telegraph to "finished with engines" and switched off the steering motors. The sudden silence on the bridge was noticeable. The only sound was the ventilation fan and the distant hum of the generator. I walked out to the bridge wing and looked down. The water was calm. The breakwater that had nearly claimed us was just a gray line in the distance now. The ship was sitting quietly against the fenders. I called the chief engineer. "Chief, we are all fast. Please investigate the main engine delay immediately. I need to know why we had that lag at the entrance." "I am on it, Captain," he replied. "We are opening the control system now." The investigation took 2 hours. The chief engineer came to my office later that evening with a small, greasy component in his hand. It was a filter from the pneumatic control line. On this class of engine, the bridge telegraph sends a pneumatic signal, compressed air down to the engine room governor. When I moved the handle from slow to full, a burst of air pressure should have traveled instantly to the actuator to open the fuel racks. The filter was a sintered bronze type designed to catch moisture and dust. It was almost completely clogged with a mixture of oil and fine particulate matter. The air could get through, but only slowly. When we asked for a sudden change in speed, the pressure built up gradually instead of instantly. That was the 20-second delay. It was a failure of maintenance, but a minor one. That filter was supposed to be changed every 6 months. It had been 8. It was a $5 part that had nearly caused a grounding. We cleaned the entire air system and replaced all the filters that night. We tested the engine response at the dock, and it was crisp. The delay was gone. The rest of the discharge in Morocco was uneventful. We stayed for 4 days, unloaded the grain, and sailed in ballast for Brazil. The departure was easy. The weather had calmed down, and we had no issues clearing the breakwaters. I remained on that ship for another 4 months. We never had another issue with the engine control, but every time we entered a port with a narrow entrance or strong currents, I found myself watching the tachometer much more closely than before. I made it a standing order that the control air filters were to be checked before every arrival, not just on the scheduled maintenance dates. It is easy to become complacent when machinery works perfectly for years. You assume that when you ring full ahead, you will get full ahead. But on a ship, you are always one small clogged filter away from a very difficult situation. If you have experienced a similar delay in engine response at a critical moment, I'd like to hear how you handled it.